Okay, we are back. This is Techmath1. We're in chapter 4 of the red book, and we're looking at 4.10. Factoring with fractions. So this is just factor and cancel is the name of the game here. So you cannot cancel things that are being added or subtracted. I can't just cancel those off. That's not how that works. They have to be multiplied in order to be canceled. You got to remember back, if I have 5x squared over 25x, I could take 5 into 25 5 times and x into x squared and get x. That's being multiplied. If that was 5 plus x and 25 plus x, I couldn't do anything. Okay? So same thing here. I can't cancel things that are being added or subtracted, but I can factor. So it multiplies to be 10, but adds up to be a negative 7. That's negative 1 and negative 10, or negative 2 and negative 5. That's negative 2 and negative 5. So we got y minus 2 times y minus 5. That is factored. Multiplies to be that, adds to be that. Now, multiplies to be negative 15. So things that multiply to be negative 15, negative 1 and 15, negative 15 and 1, negative 3 and 5, negative 5 and 3. I want the negative 5 and 3. So y plus 3, y minus 5. Now see what happens. I have them factored, and this is the exact same binomial on top and bottom. So I can cancel that off, and that's my answer. Y minus 2 over y plus 3. Now, don't do anything silly like try to cancel those y's. It's being added and subtracted. You can only cancel it if it's the exact same binomial on top and bottom. What you might want to do to remind yourself of that little fact is keep the parentheses on it, and then you think of it as a binomial instead of two little individual pieces. All right? Or that's not required, but you can have it if you want. Let's look at this one, 94, same section. We got a plus b times a minus b. On the bottom, we've got b minus a. I'm going to write it negative a plus b. Now look, I can't cancel anything as they stand, but you might notice that if I factor out a negative 1 here, I got a plus b on the top, I got a minus b on the bottom. If I factor out a negative 1, meaning I write a negative 1 out in front and then divide both of them by negative 1, I get a minus b. Now look, now they're the same, and I can cancel the a minus b's. So that is a plus b all over negative 1. I think if you look at the answer, it's got it negative 1 times a plus b, which is fine. It's the same thing. Think about dividing or multiplying by negative 1. This same result would be this. It would be the same. Or if you want to distribute it or divide it into each one, you'd have negative a minus b. That would also be fine. Either or. Okay? So that is 10-4. Good, buddy. Let's look at, well, 410. Sorry, 410. We're going to go to 411 now. All right, so 411 is going to be this. We got in the red book, let's go to page 198. That's 104. And they have a squared minus b squared over a plus b over b. So look, this is really just this. A squared minus b squared divided by a plus b over b. Now remember, we never divide fractions. We multiply by the reciprocal, so we got a squared minus b squared over 1 times b over a plus b. All right, and now we can factor that to a plus b, a minus b on the top, times b. On the bottom, we got 1 times a plus b. And look at what happens. The a plus b's cancel. And you're just left with b times a minus b. over 1, but that's the same thing. And again, if you multiply the b through and say ab minus b squared, that's fine, but you don't really have to. Let's take a look at 412. That's adding when there's a common denominator or close to a common denominator. So let's take a look at one problem like that. 109. So this is 412. And it's y squared over y minus 4 plus 16 over 4 minus y. Now, you know they're up to shenanigans when they put the number first and the variable second. That should be a big red flag that you're like, wait a second, what are you up to here? So look, if we write it forward, these are exact opposites of each other. So we'll multiply this by -1 and multiply that by -1. So do the same thing to the top and the bottom. So this one we got y squared, y minus 4. This one we got plus -16 over y minus 4. And now look, y minus 4s are the same. So we can write it once and then do y squared minus 16. And now look, we can factor that. Y squared minus 16 over y minus 4. That factors into y plus 4, y minus 4, all over y minus 4. And now you can cancel the y minus 4s. So that is just y plus 4 at the end of the day. All right. Let's look at 413. We're going to do 2 problems on there. These ones are kind of awful. They're adding and subtracting when the denominators are not like denominators. 413 is not cool. Well, let's take a look. I think we're going to need the whole board just to do one little problem. So 115, they've got 3y over y plus 2 plus y plus 1 over y minus 2 quantity squared. Oh, really? Squared? And y minus 1 over y squared minus 4. Okay, so we have to find the LCD. Ugh. So look, y plus 2, that's already kind of factored. We'll put it as a parenthesis, y plus 2. Y minus 2 quantity squared, that's already factored. That's y minus 2, y minus 2. Y squared minus 4, we have to factor it into y plus 2, y minus 2. Now, when you're finding the LCD, what you do is you take anything they have in common, remember, so here, there's a y minus 2, we'll take it. There's a y plus 2, we'll take it. And then you take the leftovers, so that's a leftover, so we'll take it, another y minus 2. So that is the common denominator. So here we are, we got 3y, or y plus 2. We got y plus 1 over y minus 2 times y minus 2. And we got y minus 1 over y plus 2, y minus 2. So now I'm going to write the common denominator 3 times underneath here. So y minus 2, y minus 2, y plus 2. Y minus 2, y minus 2, y plus 2. Y minus 2, y minus 2, y plus 2. All right, so now you look at this and say, well, what's missing? Well, it's missing a y minus 2 and a y plus 2. So that's what has to be multiplied. Oh wait, they don't want us to actually add it. I was like, wow, this is a really hard problem. Because we'd have to multiply all that out and then multiply in the 3y. Look, they just wanted the LCD. So I should have stopped right here. This was it. If we were going to continue on to add these, I'll show you what that looks like, but I'm not going to actually add them up because this multiplying would be a mess. This one, look, there's 2y minus 2's. It's missing a y plus 2. So you'd have to throw that on top and bottom. And then here, it's missing a y minus 2. So you'd have to throw that on top and bottom. And then you'd have to multiply that out, multiply that out. That would just be a trinomial and a trinomial. This one would be a pain because it would be a trinomial and then have to take 3y times everything. And then you'd have to add up all the like terms on the top. And it would be a whole other board worth of work. So they just wanted the LCD, which I should have read the problem more carefully. They just wanted the LCD. All right, let's look at one where they actually want us to add it up. That's like 1/16. So let's look at that one. It's just not as horrible as this one. So this is still 413, but we're looking at 1/16. Problem 1/16. And so they got 1 over 6y minus 3 plus 4 over 10y minus 5. This is a little more user-friendly. So 6y minus 3, we factor out a 3. That's 2y minus 1. And 10y minus 5, we factor out a 5. And that is also 2y minus 1. And so when we want the LCD, you take what they have in common first, which is the 2y minus 1, and then you take the leftovers, which is the 3 times the 5, okay? So we'll leave it like that. And so check it out. We got, let's factor this. We already factored it over there, so you just copy. You get the 3 out, 2y minus 1, plus 4, and you get the 5 out, 2y minus 1. All right, but now this is what we want. On the bottom is this LCD. So on the bottom, I don't want it to be that. I want it to be this. 3 times 5 times 2y minus 1. 3 times 5 times 2y minus 1. All right, common denominator. So now you look and say, well, what's it missing? Well, I got the 3. I got the 2y minus 1. I don't have the 5. So I have to multiply that by 5, multiply that by 5. 5 times 1 is just 5. A little easier than that problem I had on the board before where it was a binomial times 3y. All right, let's look at this one. We got the 5, yep. We got the 2y minus 1, yep. We don't have the 3. It's missing the 3. So I need times 3. It's 12, so much easier. 5 plus 12 is 17. And on the bottom, we got 15 times 2y minus 1. I did put the 3 times 5 and make it 15. I didn't distribute. You can, if you want to, you can make it 30y minus 15, but most times we leave it factored. All right. Let's look at 414. That is solving a fractional equation. So we're going to do 123. Oof. So again, this is not a walk in the park. We got 7 over 2y plus 1 plus 3 over 4y plus 2 equals 17 over 2. So now this is an equation. This isn't like what we were working with before, where it was an expression. This is an actual equation. And so to solve this equation, We are again going to find the LCD, but we're not going to find it to make them into the LCD. We're going to find it to kill it. So let me show you what I'm talking about. 2y plus 1, that's already kind of factored, 2y plus 1. 4y plus 2, we can factor out a 2 and get 2y plus 1. 2 is just 2. All right, so the LCD, look at what we have. Anything they have in common first. Well, they both have this 2. You can take it. They both have that. You can take it. And so that is my common denominator. Now, I am going to first write it so it's factored. So look, I'm going to rewrite it. So it's 7, 2y plus 1. I'll put it in parentheses, plus 3. 2 times 2y plus 1 equals 17 over 2. All right? So I just kind of wrote those as factored. Now, whatever you find to be the LCD with an equation, you can kill all the fractions by multiplying by the LCD. So 2 times 2y plus 1, 2 times 2y plus 1, 2 times 2y plus 1. Essentially what I did was I multiplied both sides of the equation by this, 2 times 2y plus 1. And I distributed it to each term. It's easier just to tack it on the top of each term, okay? So now look, 2y plus 1s cancel. That's just 7 times 2, which is 14. 2 cancels, 2y plus 1 cancels. That's just 3. 2 cancels, and now you got 17 times quantity 2y plus 1. Got to do the distributive property. Don't forget about that 1. 34y plus 17 equals 17. And now you're back to solving two-step equations. So remember, isolate the variable. So we want to get it by itself. Oh, this is weird. So 0 is equal to 34y. That's fine. It can equal 0 and then divide by 34. So 0 divided by 34 is just 0. So if I put a 0 back into the original, 0, 0, it is 7 over 1 plus 3 over 2. Does that equal 17 over 2? And 14 over 2 plus 3 over 2 is 17 over 2. Yep. So it works. You can check it back. That is it for chapter 4.